Okay, picture this. You're wandering through the Swiss Alps, maybe thinking about fondue, definitely not expecting, giant dinosaur bones.
Right. But that's exactly where today's story starts. It's quite something.
It really is. We're doing a deep dive today into Amanzia, a sauropod from the late Jurassic, and its journey to actually being identified. Well, it's a real scientific detective story.
Absolutely. Lots of twists and turns. And for this, we're mainly drawing on the scientific literature, a lot of which you can find summarized pretty well on its Wikipedia page, actually.
Good resource. So our mission basically is to get the key facts straight and understand the fascinating backstory of how Amanzia got its name.
Exactly. Unpacking that whole journey.
Okay, so the first discovery, that was way back in the 1860s, right? Sounds like it wasn't exactly a planned paleontological dig.
No, not at all. It was just routine work happening in a limestone quarry
Mm-hmm.
in Moutier, Switzerland. And these huge bones started turning up. Yeah. And you have to remember, paleontology was still, pretty new back then. Things weren't always systematically collected. Some early bits even went into private collections.
Oh, right.
But luckily, a geologist, Jean-Baptiste Grepin, he heard about it and managed to gather what was left for the Natural History Museum in Basel.
Okay, good. So they made it to a museum. But that wasn't the end of it, was it? Sounds like that's where the mix-up really started, because of a tooth.
That's the one. A theropod tooth. So the meat eater's tooth, specimen MH350 was found nearby.
Ah.
And that, understandably, led Grepin back in 1870 to think, okay, these big bones must belong to this predator.
Makes sense if that's what you find close by.
Right. So he named it, or part of it anyway, Megalosaurus mariani, after Peter Marian, a Swiss naturalist.
So this giant plant eater was mistaken for a megalosaurus. How did they figure that out? That seems like a pretty big correction to make.
Well, it took a while. Decades, actually. Fast forward to 1920. A paleontologist named Werner Jenensch looked closely at that tooth.
The theropod tooth.
Yeah, MH350. And you realize, hang on, this looks more like Labrosaurus. So that was step one.
Okay, so the tooth gets reassigned.
But the really big moment was 2 years later, 1922. Jenensch examined the vertebrae, the backbone bones from the Swiss find, and he recognized these are definitely sauropod,
Uh-huh. The shape gave it away.
unmistakably. Long-necked plant eater, not a theropod at all.
Okay, so the vertebrae set things straight, but it still wasn't called Amanzia yet, right? More name changes.
Exactly. Once Jenensch confirmed it was a sauropod, he brought in Friedrich von Huene, who was a big name in paleontology then.
Right?
So in 1922, von Huene formally named the sauropod bits Ornithopsis grappini.
Ornithopsis grappini. Okay.
But von Huene wasn't quite done. Just 5 years later, in 1927, he decided it fit better in a new genus he'd created, Cetiosauriscus. So it became a Cetiosauriscus grappini.
Cetiosauriscus. Okay, that's quite a mouthful. So that was the name for a while, but you mentioned it sort of faded into obscurity, became a nomen dubium. What's that about?
Yeah, no, nomen dubium. It literally means doubtful name. In paleo terms, it means the original fossils, the holotype material, just aren't distinctive enough to be sure it's a unique species or genus.
So like the bones were too generic, maybe, or too broken?
Kind of, yeah. Maybe too fragmentary, or maybe they just didn't show unique features, or what we call autapomorphies, to clearly separate it from other similar sauropods found elsewhere. So Cetiosauriscus grappini just sort of lingered in this uncertain status for a long time.
Scientific limbo.
Pretty much. It happens. You need really good diagnostic material to be confident.
So it sat there for decades. But then things started happening again in the 2000s. What kicked off the reinvestigation?
Well, a few things. In 2003, Antoine Heitz did an analysis suggesting, hey, maybe this Swiss stuff isn't actually that closely related to the English Cetiosauriscus. That was a hint.
Okay, little nudge.
Then, a master's thesis by Seehofer in 2005 really focused in on these Swiss remains. And then really cool find in 2007.
Oh yeah, what was that?
They found fossilized cartilage preserved in one of the limb joints.
Wow, cartilage. That seems incredibly rare. What does that tell you?
It's super rare. It gives you amazing insights into, like, joint mechanics, how the limbs moved.
Yeah.
Stuff bone alone can't really show you. It adds another layer of detail.
Incredible.
But the really decisive step, the one that finally gave it its current name, that came in 2020.
The big year. What happened?
A team, Daniela Schwartz, Philip Mannion, Oliver Wings, and Christian Meyer, published a big reassessment. They looked at everything again, all the evidence, the history,
Yeah.
and they concluded it was distinct enough to warrant its own genus. And they named it Amanzia.
Amanzia. And that name has significance, right?
It does. It honors Mons Gressley. He was a Swiss geologist, and critically, he was the very first person to discover any dinosaur bones in Switzerland, way back. So it's a nice tribute.
That's fantastic. A Swiss dinosaur named after the first Swiss dinosaur discoverer. So Amanzia finally gets its unique identity, and it's the first sauropod named from Switzerland.
The very first formally named sauropod genus based on Swiss remains.
Yeah, it's a significant milestone for Swiss paleontology. Definitely. So, okay, let's pin down its classification. Where does Amanzia grappini fit in the grand scheme?
Right. So scientifically, it goes domain Eukaryota, kingdom Animalia, phylum Chordata, clade Dinosauria, order Seritia, order Sauropodomorpha, suborder Sauropoda, and then into a specific group called Turiasauria.
Turiasauria. Okay, what kind of sauropods are they?
They're considered a relatively early diverging group of eusauropods. Maybe not as famous as the brachiosaurs or diplodocids, but a distinct lineage of these giant herbivores, mostly known from Europe, actually. So Amanzia fits in there.
Got it. And the actual bones, the original stuff, the holotype, what does that consist of?
The original material includes a humerus, that's the upper arm bone, part of a femur or thigh bone, a couple of vertebrae, and an ungual, which is a claw bone.
A claw on a sauropod.
Yeah, probably from a toe. Many sauropods had them. Now, interestingly, the 2020 team decided not to pick one single bone as the name bearer, the lectotype.
Why not?
They kept what's called the original syntype series. That's the 49 bones von Huene first described back in the 1920s. It sort of respects the historical complexity and uses that whole initial collection as the basis for the species Amanzia grappini.
49 bones. That's still a decent amount to work with from the start, and these all came from that one spot in the Rationette Formation.
Yes, exactly, near Moutier. And that formation tells us the age, early Cambrian stage of the late Jurassic, so about 157 million years ago, because it's that nice timestamp.
Crucial context. Now, have more bones turned up since or been identified as Amanzia?
Oh, yes. That 2020 paper by Schwartz and her colleagues was huge because they referred about 75 additional sauropod fossils from the same site to Amanzia.
75 more. What kind of bones?
A real mix. Some neck vertebrae, lots of tail vertebrae, which is common, bits of the shoulder girdle, the pelvis, limb bones. There are even a few skull fragments and a broken tooth, though skull material for sauropods is often rare and tricky to assign confidently.
Still, that's a lot more material to work with now. What's the preservation like? Are they, like, perfect skeletons?
Definitely not. They weren't articulated, meaning the skeletons weren't found connected together. They were scattered.
Okay.
And the bones themselves are often strongly compressed by the weight of the rock over millions of years. And, excavation itself, especially back then, could sometimes cause damage. So it's a bit like a really, really old, fragile jigsaw puzzle.
157-million-year-old jigsaw puzzle. Got it. Now, von Huene originally thought maybe 2 or 3 individuals were represented by those first bones. Did the 2020 study update that?
It did. Based on all the material now assigned, they estimated a minimum of 4 individuals. They even labeled them A, B, C, and D.
4 Amanzia together.
At least 4, yeah. And what's interesting is the size variation. They calculated that individual C was maybe 15% longer than A and B, while D was about 20% shorter.
So different sizes, but not necessarily young ones.
Apparently not. They looked for signs of immaturity in the bone structure, things like unfused bones, and didn't find clear evidence that any of them were juveniles. So it looks like we have at least 4 Amanzia, possibly adults or subadults of different sizes, living in that area back then.
It really paints a picture, doesn't it? All from these scattered, compressed bones, pieced together over, 150 years of study?
Exactly. The whole Amanzia story is just a fantastic example of how science works. It's iterative. Starts with a mistake based on limited data.
The Megalosaurus mix-up.
Right. Then gradual correction, reevaluation, new discoveries like the cartilage, new analytical techniques, until finally you arrive at this recognition of a unique Swiss sauropod.
It really highlights how our picture of the past is constantly being sharpened, doesn't it? New finds, or even just looking at old finds with fresh eyes, can change everything, even in a place like Switzerland, maybe not the first place you think of for huge dinosaurs.
Absolutely. And it makes you wonder, what else is still out there, locked away in the rocks, waiting to be discovered or reinterpreted.
A great thought to end on. That geological library still has so many chapters we haven't read yet.
Precisely. Amanzia's journey shows that the process of discovery never really stops. There's always more to learn, more connections to make, even about giants that lived millions of years ago.